Hello everyone, and greetings from a gentle autumn day here in Sydney, Australia. Today I'll be talking about the contemplative emergence part of this co-presentation with Professor Dor Abrahamson on supporting the contemplative emergence of mathematics reasoning. I'm sorry I couldn't be with you in the flesh today, though I hope that this electronic presentation is of his interest. I'd like to thank you for your attention, and thank you, Dor, for this opportunity to co-present and for all of your generosity in our work together. And many thanks to the Jean Piaget Society. My expertise is in the area of applied philosophy and contemplative education, and they both focus my presentation. For those of you who aren't familiar with contemplative education, it's an approach to pedagogy and theory that integrates contemplative practices such as meditation and yoga into pedagogy and curricula, and in some cases is directed by the philosophical underpinnings of these practices. It's a form of humanistic education defined by the educational psychologists Robert Rosser and Stephen Peck as, quote, experiential learning opportunities designed to help students develop clear, calm, and concentrated states of awareness in a context of personal growth and values, end quote. In our work to understand how increased somatic awareness may support mathematical problem solving, Dor and I have been concentrating on what we understand as a conceptual bottleneck described in this question. How can we help students reflect on their movements to characterise and describe them qualitatively as a precursor to measuring them and formulating them quantitatively within mathematical frames of reference? We hypothesise that by integrating contemplative, creative and somatic practices to mathematics, that the heightened focus they provide will allow students to remain focused long enough in the somatic and preconceptual aspects of mathematics problems for their awareness of that aspect of the problems to solidify into cognitive problem resolution. By way of an example, I'd like to tell you about a short experiment I conducted with Angela, a past student from the Meditation Lab program that I ran at UNSW in 2014. In this experiment, I sought to develop points of intersection between contemplative practice and the embodied interaction exercises for mathematics developed by Dor and his colleagues. I began by introducing Angela to a range of contemplative, slow stretching or yoga-like exercises developed to induce relaxation and deep focus in the body. From these exercises, Angela then moved on to 4 mathematically focused exercises, after which she was asked to respond to her experience using arts mediums before then speaking about her experience. One of the mathematics exercises was a low-tech simulation of Dor's technologically facilitated design for proportionality. In the exercise, Angela and I sat facing each other and I asked her to emulate me, which she did. As I placed my hands level in front of both of us, then raised my hands, gradually moving them apart to create an expanding gap, and then while lowering both hands, I contracted the gap. My aim was for Angela to retain her inward proprioceptive focus so as to remain in a light contemplative state as she followed my movements. It's this contemplative liminal state that we believe provides a space of preconceptual learning. The practice ended with Angela using a range of art mediums and then onto our discussion. And it's important to remember that Angela didn't know she was working on a proportionally focused exercise. So in this slide, Angela is working with a soft grid made of black ribbons after having done the somatic focusing exercise for proportion. This is Angela working on a drawn grid with the other grid behind her. From the feedback session, and after observing her drawing and manipulation of the soft grid, it was interesting to find that Angela's preconceptual feelings had hardened into mathematically oriented symbols, For example, in both grid exercises, Angela had crafted a funnel-like shape that grew proportionately. And then in the briefing at the end of the exercise, Angela emphasised her feeling of the size of that gap between her hands changing. And she said, "I had this real feeling of the gap between the hands, keeping the space between them, and I guess they were kind of like the fingers, and here she indicates the movable lines created by the ribbon. And just having the space in between and just feeling the space, and this feeling of rising and falling, and here she indicates the lines on the graph that she's drawn. And again, like rising and falling, yeah, I was really conscious of the space, and also, and as Angela says this, she moves her hands to replicate the space and the mirroring kind of feeling and the going up and down. And I guess it was hard to maintain the same amount of space between your hands when you were doing the exercise. You really had to pay attention, to focus. The space seemed to have a certain energy that fluctuated and changed in size, and it was my focus when doing the exercise. While the images that Angela made may appear naive, underestimating their significance and that of the foundational ground of learning they emerged from would mean the loss of a very fertile region of educational inquiry. Our research in this area follows earlier theoretical mathematical engagement with contemplative reflective states. Primarily, we draw from the work of the mathematics theorist John Mason and Wolf Michael Roth, starting with Mason's discipline of noticing. His model entails refining the natural ability of ordinary noticing, which is a process similar to mindfulness and contemplative inquiry. As with contemplative theorists, Mason identifies a natural or inherent ability, honed through practice, which can then be applied in education. He emphasises the need to work against, quote, the tendency to forget, to not notice, to be so caught up in your own world that you fail to be sufficiently sensitive to possibilities, end quote. Wolf Michael Roth also examines the potential of heightened and reflective awareness for mathematics, which he terms presence, or the state of pure being. Roth finds presence in a number of repetitive physical activities such as weeding and cycling, which can be understood as contemplative somatic practices, though he finds the ground of these experiences impenetrable. However, he does allude to primal forces at work in an original space where presence resides, suggesting that the, quote, state of pure being is not completely empty, because when consciousness explicitly returns, there's a resonance of what has been, an echo, end quote. The problem for Roth comes in the recollection of what creates that echo. And this is where we depart from Roth's engagement with contemplation or presence. For we suggest that contemplative, creative and somatic practices provides the means to enter into, remain in and return from a preconceptual ground with cognitive problem resolution. In working to explicate what can occur in the preconceptual ground of learning accessed through contemplation, I conducted an additional short experiment focused on mathematical problem solving. Working with another student from the meditation lab, who I'll call Ruth, I began by taking her through the Yoga Nidra practice. And this is a somatic contemplative exercise in which the participant follows instructions to travel through their body in a particular order. From our work together in the meditation lab, Ruth was familiar with the practice as it led her deeply into her body and internal liminal space. At the end of the 10-minute practice, Ruth was asked to let an academic problem she was struggling with arise in the contemplative state she was in. Ruth is an undergraduate accounting student, and this is the problem she was grappling with. Rather than engaging the problem cognitively, she was guided to explore it through image and sensation, such as imagining walking around the problem and experiencing its colour and size. She was also given undirected time in contemplative space with the problem. There were two stages in the results of Ruth's experience, and firstly, she saw her problem as a very solid red box with a cross marked on its lid. Then as the practice continued, a large wave broke over the box and shattered it into pieces. Before speaking about the experience, Ruth was asked to draw it, which is this drawing behind me. In describing her immersion in the liminal contemplative this way, she was able to solidify her experience in the act of contemplative drawing, and this then provided a bridge between the preconceptual and cognitive meaning making. While Ruth didn't solve the problem, she began the process as she felt the wave breaking the red box into pieces. Seeing it shatter, she realised for the first time that she could break the equation into pieces to help her solve the whole problem. Thank you for your attention, and I hope my description of these short preliminary experiments provides some insight into our work to cultivate the ineffable in mathematics education.